Good morning, students. So let's work with the concept of moment of force. What we have. So, what is the exact moment of force? Exact moments into perpendicular distance. That is called as moments. We'll solve some numericals on this part. Let's start. So, first part, slight theoretical part. What is moment of force? Moment of force is a measure of turning effect of the force about a point. Turning effect. What do you mean by turning effect? Can you analyze this one? Well aware of this part. Turning effect. It is going to turn. It is going to move. It's like a door. If you push on one side, it is going to move on the other side. That is a force applied and a perpendicular distance. So force, moment of force is measure of turning effect actually. How much the turning point is done. How much it is rotated. How much it is turned. Now, moments it depends on. Now, theoretically, what will be important is that what is magnitude of force, that how much force you are applying. If a small boy is pushing a door, that will be an another part. A big guy, adult guy, with a more strong guy, these three are pushing the doors, the forces applied will be a different. Just a simple example. So magnitude of force, it works. The length of the lever, levers, the distance will where force is applied. What is the length? Length of the lever. What is the lever? Being the perpendicular distance. Now, this perpendicular distance between line of action of force and point about which movement is taken is called a length. We consider it theoretically in physics, languages of physics, we call it as length of lever. That is perpendicular distance between line of action of force and point about which movement is taken. Now, just one example. See, suppose this is a pivot. What we are having a pivot over here, and there is one weight. This two weights are there. So if you'll observe two weights, this is a small one, this is a bigger one. This is a weight applied of 10 Newton. This is a 10 Newton weight. This is 20 Newton weight. But if you'll observe the distance from the pivot, this is at equilibrium. They are balancing each other. What they are doing? They are balancing each other. If you'll see the distance is 1 meter from the center point, that is from the pivot to the center. We are not taking distance like that. Don't consider such distance. Such distance is not considered. Remember, you should take the distances from this point. You should consider the distance. What is the distance over here? The distance will be from this point, the center. If you observe, this is the center. This is the center. This is the center of that part. So center of gravity, we have learned. You know it very well. This is a part, the center point. It is the distance of this pivot to the center. So that is considered 1 meter. Again, the distance from this point, that is again a center, that is 2 meters here. This meter, this is 2 meters. The distance considered, this is a perpendicular distance. This mathematically or geometrically if observed, it should be perpendicular. There no angle is expected. You don't learn like trigonometry. Otherwise, you have to resolve it into components. 30, 60, nothing. 90 degrees. It should be a perpendicular. So what will be the moment over here? Moment is equal to just simple product 10 multiplied by 2, that is 20 Newton meters here. And here the moment will be 20 into 1, that will be 20 Newton meter. So got the difference? So 20 Newton meters for this and 20 Newton meter for this. If you observe, both are same. I just highlight this as see. You can observe this. This is also a 20 and this is also a 20. What is the difference? Then one force is applied. The distance is more and here distance is less than 2 because the total product for the moment remains same. So as a result, both are at equilibrium, both are maintaining the balance. The moment of force is same. The moment of force, in both cases, it is same. The moment of force is the major turning effect. So this in this case, they are balanced, there is no turning effect. If one is more and other is less, there will be a turning effect. In this case, both are balanced, there is no turning effect. Okay, that is first concept. And next video will go with numericals over there. Thank you.